Python has become one of the most popular programming languages in the world since it was released in 1991. In this video, we'll be talking about its history briefly by diving into what makes it unique, how it handles many programming concepts, and lastly, how to use it with the GPIO header present on many single board computers. So, what is Python exactly? Well, it's a high level, interpreted, general purpose programming language with a real emphasis on being able to easily read and write. It was created by Guido van Rossum, developed through the 1980s. It was actually named after Monty Python, and it was finally released in 1991. Python 1.0 came out 3 years later in 1994. Python 2 came out in 2000. Python 3 was released in 2008, and it's still seeing expansions to this day. It saw a real explosion in popularity in the 2010s and is now one of the world's most used programming languages. It's used for a variety of things, including web development, data science and analysis, AI, machine learning, scientific computing, automation and scripting, even cybersecurity and some game development, as well as some desktop applications. It does have some disadvantages, though. It has a slower execution time, especially compared to languages like C, C++, Rust, and Go. It has a higher memory usage. It's not the most ideal for mobile apps. It has global interpreter lock, so it may not take full advantage of multiple cores. It has some dynamic typing runtime error issues, and it's less suitable for low-level programming compared to other languages. We also have MicroPython. That's a simplified implementation of Python 3 for micro controller and embedded systems that was released first in 2014. Kind of think of it in the same way as Arduino and C++. We also have CircuitPython. That's a fork of MicroPython by Adafruit. It first came out 3 years later in 2017, and it's even more simplified and very focused on Adafruit products. Now, the good news is Python 3 is pretty much available for just about anything. A wide variety of platforms, Windows 10, 11, server stuff for both 86, 64 and ARM 64, Mac OS, even Apple Silicon stuff, just about every major distribution of Linux, both the 86, 64, ARM 64. There's even some support for 86, 32-bit and single board computers that run ARM 64 and the older ARM V7. I think I can run Python 3 on just about every model of Pi out there. Um, MicroPython and CircuitPython, they're really good at running on micro-constrained devices, such as microcontrollers, ESP32 based stuff, RP2040s, anything with ARM Cortex M's, and even the older ESP8266, and there's even other options. However, the older AVR-based Arduinos are a little bit too limited and can't run it. You can certainly use a single board computer to program and interact with any MicroPython, CircuitPython capable device in the same way that you can use it to program Arduino. If for some reason you still need to use Python 2, there are still plenty of options out there. Although I think official support ended back in about 2010. You'll probably also want an IDE that supports Python 3. Idle and Thorny are really good options for beginners. Don't feel that you actually have to be limited to them, and don't feel you have to move on from them unless you need more advanced features. Visual Code Studio is just a good general purpose all tool for a long list of programming languages. There's also PyCharm. That's kind of the beginning of professional grade stuff. Jupyter Notebook and Jupyter Lab. That's some more professional stuff, even higher grade. There's some syntax basics to get used to. The first big thing about Python that a lot of people like is there's no delimiter character, such as a semicolon. Each line is a statement for the most part. You'll do like a print hello world. There's no semicolon or period or anything. X equal 10, print X, whatever. For commenting, you use a pound or hash sign. You can do multi-line comment blocks a couple of different ways. There's not a set standard. Triple quotes tends to be the most common way that I've seen. I think there are others. Variables are usually dynamic, so that means that Python tries to infer type from the data you put in it, but in some cases you can specify it if necessary, or else you might have to convert it. Indentation used to specify code blocks, tabs, that indentation is extremely important. There's case sensitivity with variable names, an uppercase, lowercase, everything matters. You could have three things, three names just spelled differently in terms of just the case, and they'll all be treated as different variables. Strings are sequence of characters, not unlike many languages, actually, as in C. A string is just an array of characters, but it can be handled both with single and double quotes. You can do multiple variable assignment possible, and you can even do it with different data types, because keep in mind, data type assignment is dynamic. Basic output is just a print statement. Basic input is just an input statement. That's loads easier than a lot of other languages that usually require several different lines of code to do these things. Keep in mind reserved keywords that can't be used as variables, but that's typical of a lot of languages. Now I've logged into my Raspberry Pi where I'm going to do the Python work here. So let's do a text editor. My first program is just going to be basic syntax that I wrote. Well, okay, to be fair, I kind of fudged it. And I'm just going to call it .py, but I don't think that's strictly necessary. All right, we've opened a file. I've copied and pasted in here. All right, so what is it doing? Well, it's defining some variables here. A name, which is going to be a string. Now we could have used single or double quotes there. Age, that's just going to be an int. Height, that's going to be a float. And then is student, that's going to be a bool. And again, Python is going to try to figure out all of this. We're going to list all that with prints. Um, then we're going to do a print, say in the next section, I'm going to do some inputs and look for entering a name. We're not doing any kind of validation or error checking there, so we could put in anything, I suppose. Then we're going to show off a little bit of conditional here with num, which is we're going to take in a number, we're going to convert that to an integer. We're going to do some if and else to kind of test that out. We're going to do a little bit of a for loop, a show off a little bit of a function here, nothing fancy. Um, but just to kind of show off the syntax. Now, certain key, there's no statement delimiter. Every line is a statement, as it were. This means we can't put multiple statements into a line, which we can do with other languages. Um, and you'll notice indentation at the point with if, and then with the else here, with the for loop, with the function definition here. As I said, this is really, really important. So let's run this. Let's see what happens. All right, so it's listed that data. What's our name? I don't know. Let's just say Bob. Hello, Bob. All right. Center number 43. All right, it's a positive number. Enter the first number. I don't know, 16. Enter the second number, 32. And it's added them together. There you go. And I went through the loop, our for loop as well. Now, what kind of data types are there in Python? Well, you got numeric ones like integer, float, complex. The only real text one is string. There is actually no character data type in Python. You've got Boolean, bool. But you've also got some sequence types, list, tuple, range, and set. You've got a mapping type, dictionary. None type, believe it or not, that actually is necessary sometimes. You can also always check the data type with the type function. You can always define, cast, convert types very easily in Python, actually. But keep in mind, you're not hard defining, you're kind of more suggesting when you cast, when you actually set a data type like that. Um, there are some things that are dynamically typed, but there's some instances where it's very strongly typed and it's just going to cough up an error. Um, There are type checker programs though, and some IDEs. There's a built-in one. This sounds pretty unnecessary in smaller programs, but when you get larger programs where there could be hundreds, 100+ variables, you might want a type checker at that point. All right, let's do a little program just showing off data types. Let's see, data types. All right, let's paste it in. Let's write it out. All right, so this is just a data types demo. I mean, I didn't technically made it. I made a few alterations. So integer, a float, and a complex number. Um, it's just going to print it out. It's going to show it off, and it's going to tell you what type it is with the type function. Then we're going to do text, which the only thing with text we have is a string type. Remember, there's no character data. Variable, we're going to do sequences, which lists and tuples. Um, in the case of the lists, we can have multiple data types in the list in Python, and with the tuple is an immutable list. And then we've got a set type. We're just doing set. We got a dictionary type. We're showing that. With the dictionary, you've got basically word and definition, although it doesn't have to be not in the way that you think word and definition, it's being much more generic. And then we're showing off a Boolean. Really simple. And keep in mind, none of these are being typed. Everything's being handled dynamically. All right, whoops. Okay, let's try this. Data types. All right. So yeah, 10, it's an integer, float, a complex number, our string, our list, our tuple, our set, our dictionary, our bool, and those are all the major data types. Now let's move on to output and the print function. Print function's pretty simple, but it's very powerful. It's a much simpler output than other languages. Works with objects, and it also has options for separation or separators, how to handle endings, files, and flush. So you can pass objects different ways with print. You can also change the default separator to something else. You can also change the end behavior. Normally that's new line, and normally the default separator is a space. You can change what file something's sent to. Normally it's sent to standard output. Flush buffers output normally, setting it to true. It just outputs it to display immediately. There's not really any complicated print line, write, put, etc. commands. But you can also do formatting with f strings or format print. I'm showing two examples right there. The second tends to be the preferred nowadays. There's also a low-level standard output with the sys library if you want to go that way. You can also do more professional logging with the logging library. Um, there's also special commands for that, and there's the pprint as well. All right, let's check out how to work with output. Put demo. Yeah, not a program I wrote, but something to demonstrate. Let's see. Scroll up. All right, we're importing sys, logging, ppprint from ppprint. The first is just standard print. Okay, we've done this as one argument. We've done this as two. We can do it as many as we want. This one is custom separators and ends. We can do string formatting with the format function method, and also with positional stuff here. We can do with f strings. F strings is preferred. We can do a standard out right here if we want to go a little bit more low level. We can do str and repr right here. And here's some pprint, which is not pprint, it's pretty printing. And then comparing the two. And then we've got a little bit of basic logging here. for when we want to put some professional logging into our program. Okay, let's write that out. Let's run it. Okay, let's see what happens. Basic output. We have our separators, our end behavior. We've got our format methods, our f strings. We've got our more low-level standard output write. We've got our str, and we've got our repr. The REPR is just literally going to show you everything with that, the single quote, the new line, and everything. You've got print, which okay, never mind. It shows something a little prettier, organizes it a little bit better. And then here's just some logging output examples. That doesn't look all that fancy, but it can be nice when you come to make your program a little bit more professional. Now, input with Python is actually pretty simple to get started. It's just an input function. You put whatever prompt text you want, and it returns a string, which is again just a sequence of characters. Now, if you don't want to return string, you need to convert the data, but you can just wrap the input itself if you want. So you could just wrap it in, say, int function if you're trying to get a returned int. You can also use the split function if you want to divide the return strings into multiple pieces. You can use list and map to actually put the individual results into an easily accessible list. Input validation may be very important, so you can put in a simple if then else statement. You can prevent bad data from entering your program. You can do import sys and sys.argv to allow a command line argument to be passed into the program. That can be very important. You've got argpass. This is a more advanced and professional way to handle command line arguments. You've also got, you can go back to the sys library and do a read directly from standard input. This is also something that's possible. All right, let's do another program, input demo. Again, not anything I've actually written. All right, we're importing sys and arg parse. We're doing a basic input, nothing fancy, just a standard string. Now we're doing split to show how you can separate two values. Even though there are two numbers, we're still treating them as strings. We can typecast them in terms of an integer and a float. We can do some basic input validation. We need to input a valid integer. And we're doing some exception flow control here as well. We're doing some splitting some numbers separated by spaces. We're putting them in a list and we're mapping them, including using lambda function, a lambda function up here. Doing some command line argument stuff. We're doing some arg parsing stuff as well. Doing using standard input, the read. All right, let's see how this runs. All right, let's input a name. I don't know, Bob. Okay, that worked. Let's do multiple values. Let's split numbers 5 and 6. All right, let's enter an integer. I don't know, 13. Enter a float, 4.5. All right, that worked. It added them together. Valid integer. Let's try something that doesn't work. R, that doesn't work. Okay, 5.6, that doesn't work. 5, that does work. All right, let's enter some numbers. 4, 5, 6, 8, 9. All right. To the argv, but there was no arguments. Arg parse, it didn't do anything. So we'll run this again in a second. Enter multiple lines. I don't know. Hello, my name is Bob. Control D. There you go. All right, let's run this again with I don't know, 1, 2, 3. See what happens. Bob, 4, 5, 5, 4, 2, 3, 4. And there you go. It shows our argument. It shows our first argument. Um, it kind of crashed out on arg parse though. Okay, so it wanted dash name dash age. All right, let's run that again. Let's do name, I don't know, Bob, age 73. All right, enter your name, Bob, number 564, point 4, 1, 2, 3, 4. All right. So it went through that. It showed the arguments. So with regular argv, it's actually showing 4 of them. But with arg parse, we're actually specifying so that we can actually give specific arguments. This is the kind of thing you'd see in a program. There are multiple lines. Hello, this, full D. There you go. Anyways, there's our input demo. Now, you're probably wondering how to do various things with operators, math and comparisons, and so on. Things are pretty similar to a lot of other languages. Keep in mind, 1 equal sign is assignment, 2 equal signs is equal. You've got less than, greater than, lesser equal than, greater equal than, and you've got bang equal is not equal. Logical operators, keep in mind, they don't always return Boolean values. They may actually return the actual values themselves in certain instances. Um, we've also got our usual plus, minus, star for multiply, slash for division. We've got a double slash for floor division. We've got a percent sign for modulus, and we've got double star for exponent. Um, the caret symbol in this case is used for a bitwise operator. It's and or not. There's no shortcut symbols. The shortcut symbols are used for bitwise operations. You've also got plus equal, minus equal, but you also got star equal, slash equal, percent sign equal. For those operations, that's just a shorter way of take a variable and assign the new variable. So, like a plus equal 1, just take what is an a, add 1 to it, and then reassign it to a, that kind of thing. Um, and then you've got bitwise operators. We've talked about this in some other videos, like with the Arduino. You've got and, or, XOR, um, negate. You've also got shift left and shift right. We'll probably get more into that in a later video. All right, let's do another program here. The operations demo. Yeah, let's go through this one as well and just emphasize I did not write this. All right, let's see where it starts. We define 2 simple variables. We're just going to print them out, A and B. All right, we're going to add them, we're going to subtract, we're going to multiply, we're going to divide, we're going to do floor division, do modulus, and we're going to do exponents. Then we're going to do some comparisons. Are they equal? Are they not equal? One greater, lesser, greater, or equal, lesser, and they're equal. All right. Then we're going to do our logical and, or, not X, not Y. In this case, we're defining X and Y, true and false in those cases. And then we're doing some bitwise here. A and B, A or B, X or etc. We're going to do some shifting there. We're going to do some Boolean evaluation with of different values. And then we're gonna wrap it up with some combined expressions as well, which are gonna be a little bit crazy. All right, let's write that out. Let's do Python functions demo. All right. So, yep, we got our A and our B. We add, we subtract, we multiply, we divide, we floor. Now floor just rounds it down, I believe. And then we've got our modulus. We do our exponent, so 10 to the power of 3. We false, we do true, we do whatever here. We go through our logical operations. We go through our bitwise operations. We do our Boolean evaluations. We do a whole big combined expression, which apparently turns out to be true. Now let's get into flow control, and we'll start with conditional flow control, and that's usually if then else. In this case, the word and is not included, but again, if then else is, those words aren't exactly always the same in any language. So the key here is if in a condition, you don't need braces or anything. You use a colon to emphasize to end the condition, and then indentation, again, very important for syntax in Python. Then you just put the action. That's it. Very simple if statement. For else if, it's ELIF condition colon and then indentation, whatever, and then you could just do an else in the same way. Nesting conditions are supported. That's actually true for most major languages, but I thought I'd throw that up. Short circuit evaluation. If the first condition in an and is false, it just ignores the second condition. If the first condition in an or is true, it ignores the second condition. This is very important when a language has this, because if somehow that second condition performs some sort of action, it won't perform that action when it shortcuts. You need to work around that. Keep that in mind. It's a very important tip in a lot of languages once you start to get on up there and doing programs. Comparisons can also be chained. That's not true of all languages. So you can actually put it in the middle of a range. So you can be like 5 is less than X, which is less than 9. Again, not all languages can do that. Certain values are just treated as automatically true or false. Here's a list of a couple things that are always considered false. And pretty much everything else that isn't false or being compared is just considered true. All right, let's look at some conditional flow control. Now, my example is going to use the match case, which is only available in Python 3.1. I actually wanted to see if it works in this version of Python. Actually, let me look at that version. Yeah, okay, 3.11.2, so it should. But just ignore that part if your system is just Python 3. I would say I'm trying to stick to that because that's probably pretty safe for most systems, unless they're really old, that they might still have only a Python 2, but that's becoming pretty rare. Just gonna say conflow demo. All right, let's take a look at it. I'm gonna do a lot here. So basic if else here. Doing a basic input where a positive number greater than 0, or else if it equals 0, etc. Pretty simple right there. Um, we're doing an even or odd simple condition right there. We're just doing a modulus whether or not we get it, just an if else right there. And here we're showing off we can do nested if statements. Again, indentation is very important. Then we're showing off logical operators with some more input. Well, actually, we're doing input for most of these because we want to know if username and password are equal. Let's keep going down. Let's doing multiple condition ranges, grading system. So we can keep doing else if as needed. And then there's this is the match case situation, which is switch case. Ignore this part if for some reason you don't have newer Python. And then we have tertiary operator. All right, let's run this. Actually, I think we can just do pi. No, we can't. Okay. Some systems you can do that. All right. And our number, I don't know, 40, 54. It's an even number. Okay. And your age, I don't know, 99. You guys don't get to name age. You're an adult. You are a senior citizen. Congratulations. Username, I don't know, Bob. 1, 2, 3, 4. Nope, partially correct. Okay, the password is right. Grading system, 78. Okay, it's a B. Match case example. Tuesday, right, midweek day, and then tertiary operator result positive. All right, so there you go. And then let's talk about for loops. Now, for loops in some other languages are really more counter based. In Python, they're treated more as for each loops so that they're a little bit more intuitive. Although, if you need to do counter based loops, you can achieve that with the range function. Now, you can also use an index number and enumerate as well. So basically, it's for variable and terrible, then code block. Can also loop through a list pretty intuitively. Um, you can use break to get out of a for loop, or you can use continue to skip the current iteration. I'm stumbling over words tonight. You can add else to the bottom of a for loop so that it will do something immediately after the for loop has been completed successfully. This means without hitting a break. Inversely, if something has to complete the entire loop, it might be an action was unsuccessful. Thus, the else can be used for something that has failed. Now, keep in mind this uh, fails if only happens if a break is executed. Under any other condition where there isn't a break, that else won't execute. And keep in mind also, and this is true of most languages, for loops can be nested. All right, let's see what we can do with for loops. Let's say for loop demo, copy and paste. As I remind you each time, I did not make this program. All right, basic iteration over a list. We've got a list for fruit in fruits, print fruit. Pretty simple, as I said. For each loops in Python are very intuitive, very easy to work with because you're not having to be forced to use a counter. In this case, we're doing a range, so it is closer to a counter. Works well. We can do a start and a stop. We can do a step. And then we can use the enumerate with an index as well. We can do yeah, multiple. Okay, yeah, looping multiple lists together with zip. We can loop through a dictionary here. Key and value. That's what I was looking for earlier. Anyways, nested. We can always do nested for loops. Here's how to use the break and the continue. We do a for and an else, and then what happens when you do a break. So basically what we covered. All right, let's run that. All right, this is gonna be kind of long there. All right, our basic for loops and doing it with a range, doing it with a stop and start. We do it with a step. You notice how we actually skip some things. Our enumerate loop, our zip loop, where we combine two lists, our dictionary loop, um, and our nested loop right here, our break example. So broke at 5, and then we continued. Then for else, in this case, it didn't use a break. Then it did use a break here. So there you go. Now, do while loops that you see in C and some other languages, they don't quite exist in the same way in Python. Now, a traditional do while loop is it does the thing, and then it checks a condition. So it'll always do whatever once. And if it doesn't, then it'll tell you in the language. Now, the way this works is it's a while condition, um, and the loop won't run even once unless the condition is true. What you can do is you can do something like a while true, which true is always true, so it's always going to run while. And then you put a break somewhere in there to get kind of a same sort of functionality. You can also have a while with a conditional that stops once that conditional is no longer true. So you could do like while x not equal to 10, you could do a counter in there so that eventually it will stop. All right, let's take a look at our next thing here. Let's play around with while. Let's see, while demo hi, and again, nothing I wrote myself. Do while loops don't exist quite the same in Python as they do in, say, C. In this case, we're doing a while true. So again, while true, it's just going to keep doing it until it breaks. Enter a number. Once you've entered a number greater than zero, then it'll break. Okay, pretty simple. Next one's a menu driven do while loop. You have it do something until you exit. This can be a great way in a beginner program to implement a menu. I've done this. It's basically just doing a while and then some if stuff, and eventually one option breaks, invalid choice, it continues. Then we do some validation here. It's just going to keep doing a while true, and it's going to continue until it breaks. Okay. And then this one is it'll do the loop. Once the loop gets past a certain point, it will break. All right. Let's run this while demo. All right. Enter a number greater than zero. Let's enter a zero. Nope. Zero. Nope. Zero. Nope. One. Yes. Say hello. Hello. Square number. I don't know. All right. There we go. Intro word. Five. Nope. Three. Nope. Test. Yes, it worked. And then we've done our loop executes. And once it got to three, it broke. So pretty simple. Then we have something called exception flow. Now, I'm only going to touch on this very briefly because this is a little bit more of an advanced subject. It's basically how Python handles unexpected events, also known as errors, and it is part of flow control. You've got a try code, so it tries something, and then it has except for specific error conditions, and then it has handles, which is for specific error cases. There can also be an else for when there are no exceptions, so you might try to open a file, you set an except for not file not found, you say missing file. Then finally, you might just say, okay, this finally happens no matter what. And here's some examples of some error codes out there. This is not even a remotely exhaustive list, but again, this is something I'm going to touch on in a more advanced programming video. All right, we're back for another example. This wants to show off exception control. So let's do the exception control demo. You know what? I'm going to make this just X flow demo. Shorter. Again, not something I've written myself. All right, so the first thing, we're just doing a simple try and an accept. And it's going to try to divide by zero. This is the error we're going to do, and this is what we're going to do when we get that error. We're going to do multiple accept blocks types. There's going to be a value error. There's going to be a zero division error. Then we're going to do a try except else. And if the result is right, there we go. And then try except finally. The finally is always going to run no matter what. You probably use the finally for like a cleanup step or something. Raising exceptions manually. We didn't really go over this. This is a little bit more advanced. Um, but yeah, raising an error basically it kind of lets you you say this is this kind of error under this condition. This is going to be something for a much later video. Um, nested, you can do nesting with error accepts as well. Didn't really cover this, but it is a thing. You can catch multiple errors together as well. You can do some really generic exception stuff too. Again, generic error stuff not really recommended, but if you kind of want to learn a basic and you're having a basic thing and you want to The other things aren't making much sense. You can do that. I've only done this once ever in a program, and that was basically on a class of this is how an exception works, and we looked at this for about 5 seconds. So let's write that out. Let's run this. All right. So yeah, we got our first error. We got another error. Third one, we got our else, so it's success. We did file not found, and then we did the finally raising exception. In that case, we basically said, "Hi, this is an error," and this we made it very specific with a value error. We did some nested exception handling. We did multiple exceptions in just one block. And then we did a generic error as well. Now let's talk about functions. They're just reusable blocks of code that perform a specific task in any programming language. We've already talked about a lot of built-in functions and functions from other libraries. Now, in the case of Python, functions are objects, they're data, they can be stored as variables, they can be passed as arguments, and they can be returned from other functions. These are all very important things. If we want to make our own function, we do a def, we do a function name, we do our braces, we do our colon, we do our return in an indentation, and then we do our call block. Can't emphasize enough the importance of indentation in Python. Now it can take in multi-parameters. They even don't have to be typed. You can set default parameters, especially when a parameter is optional and not specified. They can do something directly, or you can return something. You can do one asterisk to prefix a variable when you don't know the number of variables. Two asterisk prefix would be for keyword arguments. Keep in mind with variables, the scope rules for Python are local, variables inside the function enclosed. So if your function is inside another function, then it looks at that outer function, then it looks to global variables in the program, and then it looks to built-in variables. Um, Keep in mind there are methods in Python. There's classes and other stuff. Again, a future video, function and method are not the same thing. Methods belong to an object. Functions are standalone, or as I sometimes call them, freewheeling bachelors. There's many built-in functions. Libraries can add so many more. You can also just import specific functions or features from a library. You don't have to import the entire library necessarily in Python, and also in a number of other languages. All right, let's do a program showing off functions. Let's see, functions demo. Again, disclaimer, I did not make this, just copying and pasting it. All right, so our first initial basic function, pretty simple. All it is doing is printing hello and we're calling it. Okay, simple enough. In this case, we're actually returning something. We're taking an A and B, we're adding them, we're returning it. Okay. Then we're doing some default arguments here. What happens if we only bring in a base number and not an exponent? Well, then let's just assume an exponent of 2. All right. And then let's talk about scope here. We talked about local versus global. I mean, there's also enclosed and built in. Um, Now, keep in mind the word global here. So we're defining a global variable, something that's not just local. All right. And then let's look at we can nest functions inside of each other. That can be very useful. We can also call functions in each other too, functions as objects or what they call first class citizens. I'm not sure if that's actually official or unofficial. Um, but yeah, I mean, we can assign a function to a variable here. Now keep in mind, uh, methods are in classes. That's kind of related to a Java thing, but this is something also in Python. The two things are completely different. Built-in function versus a method function. We're showing off, well, sorry, function versus method. See, I even make that mistake. And then here is a function just for returning multiple values. We can have it return multiple things. Okay, let's save that. Let's run this. All right, let's see. Basic function, hello from the function. Okay, we do our addition here, different arguments. Remember, where the default is an exponent of 2. Our scope rules, local, global, and then after modifying the global, nested, outer, inner. All right. Functions and objects stored as a variable. All right. Function versus a method inside a class. We've got our function, we've got our method. All right. And then returning multiple values from the same function. Now, we've taught in other videos, we've talked about sleep, delay, whatever, because there's times when we need to pause the program, stop the program from executing, delay, whatever. This is a full-fledged language, so there's a number of things you can do. The simplest way is just to import the sleep function from time, or just import the entire time library, and you can just sleep for a number of seconds. It just stops the program, or blocks, blocks further program execution. Pretty simple thing. But there are other alternatives, and there may be better options for what you need. Timestamps may be better. You can use the time function so that you can track the time. So you might set a start time, or you might want to know the time when this started, that's started, and then base your delays or whatever off that. There's something for a synchronous program. So maybe your program is actually doing multiple things at the same time. You don't want the entire thing to stop or to delay. You just want part of it. And then you can get into threading. It's a little bit more of an advanced feature for another video, but you can basically use a timer in that case, and you can just say a function is supposed to run after a certain delay instead of blocking the actual rest of the program execution. There's time schedulers for something even more scheduled, again, advanced videos. There's stuff for GUI based delays. Conclusion to take from this is be smart with how you pause, block, or delay your program. Find the method that best fits what you need. A lot of people will do some while loops just to keep things from moving forward for a while, and I guess that's fine for early programs for learning, but don't get into a habit of using it. All right, let's look at how blocking, pausing, delaying might work. Let's see, I don't know, we'll just call it delay demo. Again, disclaimer, not my own work. All right, so we're bringing in time, threading, schedule, async IC, Tkinder. All right, first thing we're just going to show sleep, and we're going to use time for showing start and end time. Okay, pretty simple. We're doing threading here with a threading timer. After a delay at 2 seconds, we're doing something. Okay, pretty simple. All right, schedule module. This has a little bit more power to it. We can set arguments. We can do a couple of things with it, and we can run. And then this is for asynchronous delay. Yeah, here's the asynchronous task. Everything. Then busy wait. Not recommended doing this. This is the whole while thing that I mentioned you really shouldn't do. He's Tkinder. There's a little bit more setup for this, but it's meant to be a GUI. I'm not sure it's going to run because I've never used this before, but let's see. All right. Okay, and there's no display for Tkinder, so we can't actually show anything. I figured that would be the case. Now, since some of the reason I'm covering Python is for single board computers, we really need to talk about GPIO. Raspberry 3, 4, and 5 have 40 pin GPIO headers, and about 26 of those pins are directly addressable by Python libraries. The two major libraries to use for Python are RPI GPO, that's older, and then there's GPIO 0, that's newer. But then there's some alternatives. There's what I call Pig PIO, but I know it's Pi GPIO, just Pig PIO sounds funnier. Lib GPIO, um, Periphery, which I've never used, but I've heard things, and then wiring pi, that's really old. Do not recommend using it. I literally used it with my original Model B, and I'm talking Model 1B. Um, you can also do some direct bit banging against Linux devices, as GPIO pins and pretty much everything else on it is just everything is accessible as a device under Linux. That's just the way it works. In fact, very old school method when libraries were just not out for this stuff. That's what people did at first. For I2C, you have SMBus and SMBus2. You may have to install these things though, and then depending on your setup, that might be a little bit of a nightmare with pip. Um, but you also have some I2C functions and Pi GPIO, and you can make low level device calls. SPI dev for SPI, but again, Pi GPIO also has SPI functions as well. Low level device calls. Pi serial for UART. PI also has UART functions, but it's still going to need Pi serial. Again, low level device calls. Software serial isn't quite the same thing with a single board computer as it is with an Arduino, but you can do manually bit banging and some other stuff with Pi GPIO, pulse width modulation, RPI, GPIO, GPIO 0. You can do hardware, you can do software. There's many functions for specific components, but you'd be surprised what you actually have to do on your own. But that's going to show you that just because something in, say, Arduino does it, it doesn't mean it's complicated. It could be 4 or 5 lines of code, and you'll realize just how simple it actually is. All right, I'm going to show some GPIO stuff. Now, I can't actually show blinking lights or anything connected to everything, so I'm just going to show the program I'm going to run it and show what you'll get, on the console here. Again, I did not make this myself. All right, so I'm just going to show off a little bit of stuff. I'm not going to go on everything from the slide. So RPI.GPO, some, as I said, it's classic stuff, not too old. I'm not showing wiring pi, even though I have used it, but you should be able to easily get this. I'm setting a pin mode. I'm using BCM moding. I'm setting up a particular pin 18 as an output. We're just going to be blinking a light, doing a time sleep. Um, Oh yeah, okay, we're importing time at the whole beginning of this. I was wondering where that was. Pretty simple. It's all 18 is on. It's waiting for half a second. It's going off. It's waiting for half a second. Blink, and then eventually it's gonna just do. It's gonna keep doing this for a couple of times, and then it's gonna just clean itself up. And then with 0, it is basically doing the same thing. GPIO 0 is a little easier to use. Not that the classic thing is difficult at all. Um, but yeah, basically the same thing. Um, yeah, GPIO 0 is a little bit more high level. Not that I think RPI.GPO is really not much more complicated than Arduino, but you want something even easier. Um, IGPO, which is what I like to call it, um, just setting it up, same idea, very, very similar. Um, certain thing, I mean, PI GPIO has a lot of functions and features that you have to go elsewhere for some of those other ones. Uses a whole precise control. It has its own daemon program running. Um, but yeah, let's just write this. Let's see what kind of text we get, if anything. Oops. Hmm, something doesn't work. Okay, maybe something's not connected. Hmm. Okay, apparently RPI GPIO isn't working on this Pi. Might try another one, but for the now, I'm just going to comment it out. Let's see what happens now. Okay, so GPIO 0, it's going through that. Oh, and it can't connect to PI GPIO. Let's start that up. All right, let's try that again. Hmm. So you can't connect to specify. Yeah, I'll have to fix something with the daemon. But anyways, that's all you see anyway. You wouldn't see the lights blinking, so it really only worked with GPIO 0. All right, I brought it up on something else and it works fine on here. Or it was. Hmm. Okay. And that's what we should see from the console. So, just to wrap things up, Python is high level, interpreted purpose programming language with a real emphasis on being easy to read and write. 3.0 came out in 2008 and it's just commonly supported. Older systems might still be on Python 2.0. This presentation really focused on 3.0. There are some disadvantages to Python: slower execution times, higher memory usage, some dynamic errors at runtime in some cases. You've got micro Pythons and circuit Python variants, kind of akin to how Arduino is a simplified dialect of C++, and they're for certain microcontrollers, embedded systems. But Python can be installed on a lot of different platforms, several ARM variants, and just about every major Linux distribution out there. Windows, Mac OS, a lot of things. The only thing it's not supremely good for is Android, iOS. There are things to install it on there, but again, it's not the most ideal for those platforms. It has a probably easier than average syntax. There's no statement delimiter, but indentation is extremely important. There's a lot of different variable types, but variables are dynamically typed, but you can suggest the type. Output and input is really simple, but there's a number of very powerful options for these. There's plenty of flow control options, but it currently lacks switch cases. There is a thing known as match cases, but they're only available in 3.10 and higher. I'm focusing on things that are unique to 3 right now. And there's plenty of options for exception control as well. I talked about there being plenty of options for GPIO control for single board computers. Well, until next time, have a good one.